A graph is a way to summarize data into an organized demonstration that could be read quickly. This is a bar graph. As the name indicates, a bar graph uses bars. Bar graphs represent data based on frequency, or how often. In the case of a bar graph, bars show a specific category. This graph shows the number of cars sold by a dealership during 2006. To build a bar graph, first decide the size of the vertical scale. Because from the table the highest number of cars sold per month is close to 100, that is the limit set for the graph. The division of the scale is set at 10 for neatness. The horizontal scale was set per month because that is the way sales commissions are computed. Now, unlike in the bar graph, in a histogram each bar represents a range of data. The intervals selected are the actual commissions earned by the salesperson. Notice that selecting the size of the interval is important. If the intervals are too few or too many, the graph loses meaning. Now to circle graphs. Circle graphs are also called pie charts. Although circle graphs have limitations and cannot be expanded like a bar graph, they are an excellent way to present fractions, portions, or percentage. This circle graph shows a budget. Notice that all percentages add up to 100%. To build a circle graph, you must recall that a circle has 360 degrees. Therefore, the piece of the pie devoted to, for example, 7%, has to be proportional to the other pieces of the pie where 100% equals 360 degrees. So, 7 is to 100 as angle is to 360 degrees. Angle equals 7 times 360 divided by 100, or 25.2 degrees. The angle for 7% is 25.2 degrees. Each portion of the circle graph must be calculated the same way. Let's build now a circle graph with fractions. This circle graph shows how a city spends taxes. Similarly, forming a circle graph with fractions equates a fixed amount, in this case 1, with 360. For example, the angle of the piece of the pie devoted to parks will be 1 over 8 is to 1 as angle is to 360 degrees. Multiply and divide. Angle for 1 over 8 is 45 degrees. Now we move on to plots. Plots are built from points that define a location. The location of points in turn may or may not develop into recognizable patterns that define the direction a set of data is taking. Dot plots may be used as an alternative to bar charts, and many researchers prefer them because they are cleaner and easier to read. For example, this dot plot shows the same data as a bar graph, yet it is simpler to produce and easy to read. Another set of interesting tools that are used to present data are called box plots, stem and leaf plots, and scatter plots. This is a box plot. Box plots, also called box and whisker plots, besides establishing location, contain data on the median, upper quartile, lower quartile, interquartile range, upper limit, lower limit, and outliers, which are also called far-off points. To build a box plot, first, organize the data from lowest to highest. Second, find the median. That's the number where half of all data is above and half is below. Third, find the lower quartile. That's the number where 75% of all data is above and 25% is below. Fourth, find the upper quartile. That's the number where 25% of all data is above and 75% is below. For example, build a box plot for the data shown. Find the interquartile range, the upper and lower limits, and outliers. First, organize the data. Because there are 16 numbers, an even amount, the median must be after the 8th number, half of the number, but before the 9th number, in the middle of 78 and 80, or 79. The lower quartile must be in the middle of the first 8 numbers, after the 4th, but before the 5th. Add the 4th and 5th number, divide by 2, and the lower quartile is 70. The upper quartile must be in the middle of the last 8 numbers, after the 12th, but before the 13th. Add the 12th and 13th number, divide by 2, and the upper quartile is 89. The interquartile range is the distance between the upper quartile and the lower quartile, or 19. Outliers are those numbers that fall beyond 1.5 the distance of the interquartile range, or multiply 19 times 1.5 equals 28.5. Add 28.5 to the upper quartile and subtract 28.5 from the lower quartile. 28.5 plus 89 equals 117.5, and 70 minus 28.5 equals 41.5. Any numbers below 41.5 or above 117.5 are not worth considering because they are outliers. Therefore, both 40 and 120 are classified as outliers, and the upper limit falls to 100, and the lower limit moves up to 55. Now, to build a box on a scale that includes all numbers observed, draw a box with the lower quartile and upper quartile as the size of the box, and draw a vertical line dividing the box at the median. Add lines, the whiskers, to the lower limit and upper limit. Mark the outliers, the O's, with an asterisk or a cross. Now to the stem and leaf plots. Stem and leaf plots are frequency plots that are used to organize data and determine central tendency. The idea is to split every number into 2 sections. The left part is the stem, the other the leaf. For example, the number 123 would be split 12/3, and the number 48 4/8. A column of the stem is matched by a row representing the leaf. For example, make a stem and leaf plot of the following airplane takeoff waiting times in minutes. The stem will be the 10 digits and the leaf the 1 digits. The central tendencies may be checked by looking at the distribution. In this particular case, the data is skewed or leaning towards the lower values, while the median is 21 minutes and there are 6 modes. This means that there are poor central tendencies. Notice that the stem and leaf plot looks like a horizontal histogram. They both have intervals and frequency. A benefit of the stem and leaf plot is that it displays all the individual values within the interval, while the histogram does not. The last plot we'll visit is the scatter plot. Scatter plots are used to summarize how a set of data behaves when compared to another set. Called correlation, it is a way of checking patterns of plotted points using 2 variables. The more the points tend to lump together to form a distinctive group that shows direction to the verge that they look like going somewhere, like a flock of birds, the stronger the correlation. Correlation means that the variables follow each other, and you can then predict one from the other. There are 3 ways of reading a scatter plot. 1, if they aim towards the northeast, lower left to upper right, the correlation is positive. 2, if they aim towards the southeast, upper left to lower right, the correlation is negative. 3, if the points are random without showing any particular aim, the correlation is very low.